All right, we're going to go ahead and get started. Welcome to today's CNCF webinar, Creating an Effective Developer Experience on Kubernetes. I'm Bob Killen, Senior Research Cloud Administrator for the University of Michigan. I'd like to thank everyone for joining us today. We would like to send a warm welcome to Daniel Bryant, Product Architect at DataWire. He will be our presenter today. We appreciate him sharing his expertise on effective developer workflow with our listeners today. Before I hand it over to him, there's just a couple housekeeping items. During the webinar, you are able to talk you are not able to talk as an attendee. Sorry about that. There is a chat window at the bottom or the Q&A function. Please feel free to drop your questions in there, and we'll get as many as we can at the end. The session is being recorded and will be sent out afterwards along with a link to the presentation. With that, I would like to go ahead and hand it over to Daniel.
Awesome. Thanks for the intro, Bob. Great stuff. So let's get started. So the title itself may be a little cryptic. I'm not sure everyone's heard of developer experience yet. So I thought I'd just start by introducing some of the kind of concepts a little bit pictorially, and then we'll look at the actual text as well. So for me, developer experience is primarily about having this great idea, maybe a hypothesis, a new business kind of idea or whatever, taking all the resources we've got, and I'm going to use the container and the shipping yard analogy because we all love containers and shipping yards, yeah. But we've got this idea and these resources. How do we get it to our users delivering business value? Making their day better, making their lives easier, delivering some form of value. Now, most of us, if you're here, you're probably interested in deploying apps using something like Kubernetes and containers and so forth. So pretty much, I'll use the container metaphor exactly here. Developer experience is the bit in the middle, the bit that taking our ideas through to delivering value. Now, using the shipping analogy, it's pretty much the loading of the containers, it's inspecting the manifests, and when something goes wrong, knowing how to fix it. That's kind of the key developer experience. That's a good developer experience. They can be hard to quantify sometimes, but I'm sure many of you listening recognize a bad developer experience. Maybe you've got that kind of tool that promises great things, but it constantly falls over. And I've certainly had that in my career. Or maybe you're getting close to production, or you're in production, something falls over and you can't figure out what's going on. You can't debug, you can't observe. Now, this for me, this bit in the middle is fundamentally the experience I have as a developer or an engineer, and it is really important to get this right. And with every new technology that comes along, I've been in the industry about 15 or so years now, the developer experience subtly shifts from kind of SOA to monoliths, now to microservices and containers and so forth. And we as engineers need to kind of adapt our experience. If you're a platforms engineer, you need to adapt what you're offering, say, your users, your developers, your engineers. And if you're an engineer yourself, you need to adapt to the platform, work very closely with the ops team, with the platform team to help figure out exactly what we do need to create that smooth kind of path from idea to delivering value. The kind of TLDR really today is that developer experience is all about minimizing the friction from the idea through to the code and the config to delivering business value. And that business value must be observable. We must be able to quantify it in some way. How you construct your platform, and I'm using the term platform loosely, we'll dive into this more in a moment, very much impacts the developer experience. Yeah. And high productivity and bottom line kind of fun as an engineer comes from intentionally designing the experience of things like local development and debugging, packaging apps, CD, deployment control, and observability. So that's the kind of, the high level. And what I'm going to do now is spend, 30 more minutes or so unpacking some of these ideas. It is going to be a conceptual talk, not with lots of code on the screen, for example, but I'm trying to get you to think about the developer experience with Kubernetes. And hopefully there's some links that you'll find useful for going into more of the details with only sort of 40 minutes to talk or whatever. There's only so much opinion and so much code you can kind of share. So I'm going to focus more on the concepts. This is me at Daniel Bryant UK on GitHub, on Twitter, on LinkedIn, and so forth. I started my career as an academic, moved through to software development, working from everything from small startups to government departments. I was a CTO at a couple of small companies, done some training, and now I'm working with a company called DataWire, a Boston-based company. We're focusing very much around developer experience on Kubernetes, and we've got the CNCF-hosted tool, Telepresence. We were the creators of that, and we also do the Ambassador open source API gateway as well. Shameless plug, I'm writing a couple of books, so I'd love your feedback on the books as well. You can see the links down the bottom there. I'll share the slides later. But I do realize throughout my 15 years as an engineer, it's as much about the teamwork and the people as it is about technology. I love containers, love Kubernetes, love Java and so forth, but I've realized that to really get the best out of my team and have the most fun and deliver the most value, we've got to think about the whole experience. And that's what we're going to look at today. So setting the scene, cloud native is a thing. If you haven't heard, it's a thing. Yeah, we've got a whole foundation now, the CNCF and so forth, and it really is driving all forms of software development. I definitely look towards the CNCF. I've been to KubeCons and the Cloud Native Cons, fantastic conferences, and I do sort of lean towards the CNCF for my definition of cloud native. I know there's a new definition coming out. If you're involved in the talk, you're sort of seeing some new definitions coming around. But fundamentally, what the CNCF are saying with cloud native tech is it's container packaged and dynamically orchestrated or dynamically managed. And we're typically developing new applications using sort of patterns like microservices, like event-driven architecture, and reactive kind of frameworks, things like that. At Dedawar, we've talked a lot about this being sort of a flywheel. If you get the cloud native thing right, we've kind of got sort of 4 bits to our wheel here. If you get it right, it's a virtuous circle. You can go so much faster, and you can vary sort of development experience across your teams depending on who needs to go fast or who needs stability, these kind of things. So feel free to explore these links. I'd also recommend having a look at Sam Newman's idea on cloud native. Sam is a slightly contrarian view here, but I always like Sam's work. Sam has created the Building Microservices book. I'm sure many of you bumped into his work. Always enjoy chatting to Sam, always learn a bunch. And this talk is a bit different in terms of Sam's talk here about what cloud native is, but it's a nice kind of thing to read to sort of fully summarize our view of what cloud native is. But I'm going to mostly assume, we're building microservices, we're pushing sort of code down a CI/CD pipeline, and we're packaging in containers and deploying in Kubernetes for this presentation. Fundamentally, when you look at the cloud native experience from the sort of more platform side, it is infrastructure. There's always some kind of VM or IaaS or whatever. You're building a platform on top of that IaaS. So, we're going to choose Kubernetes, but you need some other machinery around that platform, around that container orchestrator to provide the full experience as a developer, as a tester, as an operator. Workflow is super critical. These are the 3 kind of things I look at. And I did an article on DZone a couple of weeks ago, actually. And I think it's kind of like Maslow's hierarchy of needs. You definitely need to get the infrastructure right and then build a platform on top, and then correspondingly create a workflow. But I also think it's more, the workflow can have a bigger impact on velocity and business value. You've got to build on firm foundations, but how we as engineers work together and create code from idea to value it really makes a massive difference. If you don't invest time in it, in my experience, you can have the most amazing platform in the world, but you still might be slow, or you might have systems falling down around you, for example. We're going to be focusing on the platform and workflow today. What is workflow? Critical question to ask. The platform heavily influences the workflow. So how you use Kubernetes, how you interact with Kubernetes as an operator, as a developer, makes a massive difference. And then if we've got time, I'm going to be conscious of time because these slides are probably an hour's content really, but we're going to dive deeper into a few patterns of good practice as well, where I'll pick on a few tools like things like Scaffold and GitCube and a few other ones, telepresence, just to kind of some lessons I've learned working with a few clients and so forth, and try and share some of the best practices around those. So what is workflow? Well, the ideal workflow has very much shifted over the years. When I entered into the industry, 15 or so years ago, we were still doing waterfall. And, waterfall isn't necessarily a bad thing, but waterfall assumes that you know all your requirements up front. If you're building kind of, defense systems, which is where this kind of model came from, arguably you would know a lot of these requirements up front. If you're building bridges, for example, and, to look at more of a real world scenario, you know requirements up front. But with software, we often don't. We have hypotheses, we have ideas, but we need to validate them. And therefore, Agile become the de facto way of doing things because it's kind of waterfall, but in smaller iterations, and we can loop back. We're increasingly getting a tighter or needing a tighter feedback loop now. I've taken this graphic from a Netflix blog. I'll share the link later in a minute. But we really now need to focus on maximizing the sort of minimizing the time to value, maximizing our throughput. And the Netflix team talk about very much around having cross-functional teams. And these teams have got developers, they've got QA, they've got PMs, they've got everything you need to basically offer a product So they're moving sort of away from projects, say, to products. They're now offering, the streaming playback service, or in Netflix's case, or they're offering some kind of analytics service. And this puts a lot more demand on individual engineers and teams of engineers and the platform itself. And that kind of, comes together as an experience. We're looking particularly at Kubernetes, and I've pulled apart some of this stuff on the DataWire blog. Fundamentally, you can see on the bottom left of the diagram there, we have our idea. You might need to do some sort of coding locally. You deploy it to Kubernetes, you experiment, you canary test, all these kind of things, and then you measure the impact using maybe like a tool of Prometheus, something like that. Now, a lot of these tools, the different stages here are interchangeable. You can kind of, create your workflow as you desire. There's also sort of some core ideas like GitOps coming up around that sort of how the whole workflow is assembled. But fundamentally, these for me are the 5 key stages in the workflow. We have our idea, we code, we deploy, might sort of iterate there, we experiment, we canary, we sort of ideally with real users, and then we measure the impact we're having, and we go back around the loop. I saw a fantastic talk by Stefan Tilkov in Berlin, I think it was, in March this year at MicroExchange. And he talks about how most of us are moving towards building services using autonomous cells, kind of picking up on the Netflix analogy here. Kind of Conway's law type thing as well. The structure of your organization dictates the look of your software, effectively, how you assemble software. And this we're finding is a good thing. Developing in small cross-functional teams allows us autonomy, allows us speed, and so forth. But one slightly negative anti-pattern you can see is that, particularly if you're developing with multiple languages, I worked on a project with Java, Go, and Ruby, is you start implementing bits of the platform in each of the language services. So you might have like a Java service discovery mechanism, a Go service discovery mechanism, a Go circuit breaker, a Ruby circuit breaker. And before long, you've got these kind of library components spread across your services in code, and you've literally got the micro platform problem where you want to update, say, the circuit breaker, but you have to update it in multiple different libraries. And this is really hard to do. Hence, we're discovering a good pattern is to push a lot of this responsibility down into the platform, so that you look at things in particular. Kubernetes is a good example of this with deployment, and even more recently, we're seeing things like service meshes, in particular Envoy, doing amazing work that allows us fine-grained deployment control and things like circuit breaking and all this kind of good stuff at the communication level, but providing a centralized place. We control all the circuit breaking, say, via the control plane, but the data planes are running as sidecar proxies, and we can update them all completely separately from how we update our apps. Yeah. So what we see is kind of like this in a typical organization. You have multiple teams. I've just picked 5 here, for example, probably working at different paces. I might have some code, in this one here. This team is working. It's a well-established product. We're looking for stability, perhaps more than we are velocity. Whereas over here, we've got a completely new idea, new product, and we want to go slightly faster. We want to perhaps, same kind of loop, but we want to do slightly different things. I think we still, as a kind of organization, we need some cross-functional support. We need some centralized support. We often need subject matter experts, SREs, platform architects, infrastructure people, ops people. There's a lot of value in being specialized in certain things, as well as being cross-functional in individual product teams. Now, to support the subject matter experts, you clearly need your Kubernetes cluster, and you need things like developer tooling and the CD and observability tooling. And how you offer those, or how you create those, very much impacts the developer experience that is felt in the teams around the outside here. So that's pretty much it. The platform drives the developer experience. The platform drives the workflow. Now, the CNCF vision is fantastic. I don't know if anyone's bumped into the landscape, the Cloud Native Trail Map. When I first bumped into it, it really helped me sort of understand some of the key components within the actual CNCF landscape. There's clearly Kubernetes mentioned, there's Container D mentioned, there's Prometheus, all these kind of good things. And it talks about sort of a journey you might go on when you're looking to move to a cloud native kind of experience. Now, the thing with the CNCF vision is it's primarily focused at the ops level at the moment, I think, obviously my opinion there. I think the developer experience is equally important. Platform and developer experience are super important. I actually created a sort of little blog post and shared a Google Doc to open up sort of comments to try and understand what other people think as well. Yeah, the trail map is clearly useful. I have many good conversations, but I'm kind of curious, what do people think when they're developing cloud native apps from a more of a developer standpoint? How do you establish CI/CD? So you can follow that link there, read the, please read the Medium post and then have a look at the Google Doc. Please feel free to contribute. I'm trying to kind of create a not a definitive guide perhaps, because everyone's context is subtly different in the way they're developing applications, but at least trying to create a place where people can sort of share best practices, share good ideas around developer experience. Got to quote Kelsey, of course, any kind of talk you do on Kubernetes. One thing I really like about Kelsey is his observations in the industry in general. And I'm going to quote this particularly. I'm convinced the majority of people managing infrastructure just want a platform as a service. The only requirement is it has to be built by them. Now, I think like Kelsey was spot on with this, and I even see this with Kubernetes. Kubernetes is fantastic, but it doesn't provide perhaps enough PaaS-like functionality yet. And there's good reason for that. I'm not denying Kubernetes was built on some fantastic primitives, but we often need to put a few more things on top of it to be fully useful. Now, Kelsey goes on to say, it's not a bad thing, basically, if you're building a PaaS, but recognize what you're doing. Yeah. And this is a key thing. And I'm going to explore a few questions now to get you thinking when you are looking to create your developer experience, where should you be investing your time? Because you've got to remember, every sort of moment you spend creating a PaaS or creating a workflow is opportunity cost. You could be developing other perhaps business value functionality or whatever. Maybe you get more value by using something like an OpenShift or something with more PaaS-like functionality on Kubernetes already. Maybe something like a Cloud Foundry or whatever. It's really important to know and recognize you're making a choice about how you're creating your developer experience. Not necessarily bad one way or the other, but do recognize what you're doing and make the choice consciously rather than unconsciously. What I am seeing now, I'm very lucky. Part of my job, I get to go to the KubeCon conferences, which are always fantastic. I recently got back from New York. And last year in New York, I saw the Netflix team talk about how they're creating this paved road PaaS. They, I believe, are building on Mesos, actually, so they're not using Kubernetes, but a lot of the principles are the same in that they're providing a paved road in kind of a centralized team offering a platform and offering support for you developing your applications as an engineer. And then if you stay on this paved road, they'll give you help, they'll give you support, and really sort of work with you. As a Netflix engineer, they really value freedom and responsibility. We're all grown-ups, as they like to say, and you have the freedom to do what you want. But if you do divert off the paved path, if you suddenly want to do some kind of different, circuit breaking or something, you're welcome to, but then you have the responsibility to look after that. You're probably on call for that. And I like this model a lot. And we're seeing people starting to do this more and more now with Kubernetes. Awesome talk I saw at KubeCon New York by Nico from Shopify. He talked about how he and his team have built a PaaS, a kind of paved road PaaS, on top of Kubernetes. And they've done this through things like using custom controllers and operator style things, which we can look at a bit more in a second. But I've written up this talk on InfoQ. You can pop along and read more about it. And Nico really talked about some of the decision points they've made as a team along the way. When they decided on cloud, they decided on Kubernetes, and they come up with a bunch of problems, and they found even more along the way. But it's really nice to understand someone who's already done this journey, sort of learn from someone who's done this journey as well. So please do check out Nico's talk there. So the key question, should I build a PaaS on Kubernetes? Should I build some form of platform? Key questions I like to ask with clients is, when you're developing and testing, do you want to do everything locally using something like perhaps Minikube or Docker for Mac, these kind of things? Or do you want to do more stuff in the cluster? Do you want to have a Cloud Foundry-like experience where perhaps even people don't install Docker or anything container-related on their local machine? They just git push and they work with the cluster remotely. So at Dedawar, we've kind of come up with a bit of an infographic here, trying to weigh off some of the benefits. It's all a trade-off. We're not saying like one way's better than the other. If you run everything locally, it's probably not realistic to production. I'd also argue if you do need to spin up everything locally, you might have a slightly highly coupled system, kind of a bit of a distributed monolith if you're not careful. And also, I work with many clients who simply cannot spin up their entire system locally. Just resources, or there's a legacy system or a third-party system they cannot spin up locally. Now, on the flip side, if you move to all remote development, you lose some of your debug tools locally. yeah, which is quite tricky. So working locally has many advantages. You're definitely not running lots of things in the cloud, or not running lots of clusters, for example. Some people do want to maintain these minimal development environments. They want to hide Docker and Kubernetes from developers. I don't think that's a bad thing. Again, it's just a decision. Knowing the maturity, the skill level of your development team, do you want to expose them to things like Kubernetes? Because let's be honest, I'm sure many of you watching the webinar are fans of Kubernetes, and you know Kubernetes quite well. But when you try and explain it to your friends, you suddenly realize how much there is to know of Kubernetes, how much there is to know of the surrounding ecosystem. It's quite a lot to take in. And many developers just want to write code. They just want to get stuff into production, yeah? So Docker and Kubernetes can be a distraction. There is a kind of hybrid approach, which telepresence I've mentioned already. It's a CNCF-hosted project now. It's basically a two-way proxy, allowing you to proxy into a remote cluster. So you can spin up all your services in a remote cluster. You can then spin up a service locally, say, with all your debug tools. I'm often working on Java services with IntelliJ. I run telepresence, and I can work on one service as if it was in the cluster. I'm working locally, but it's proxying two ways. I can pump in a request sort of via the UI, see what happens, and I can even debug locally on my machine because my machine sort of thinks it's in the cluster. So that's a kind of hybrid. Tools like Squash, fantastic tools. Squash is very similar kind of approach to telepresence, but it's using the Envoy proxy. It's using service mesh capabilities. So key question, how much of the workflow do you want to expose in terms of Kubernetes workflow? Do you want to expose to your developers? That's probably a key thinking point. How quick do you need user feedback is another thinking point. Now, many companies, many of the sort of unicorns, and I appreciate we're not all unicorns, far from it. We're not all Netflix, we're not all Google, but canary testing is becoming very powerful. And I'm working with companies that are not, definitely not Netflix, but they're really embracing canary testing, pushing things to live, hiding things behind feature flags or kind of smart routing, and then getting a very small amount of their traffic, their live traffic, diverting it to these canary deployments and looking for KPIs, things like tech KPIs, but also business KPIs, and understanding, is the thing we're doing now making the system better or making it worse? You kind of A/B test these things. It does need app and platform support. You're going to need to put the metrics into your apps, exposing the KPIs, and you're going to need to kind of hook up all the observability bits and pieces. Now, Netflix have got an awesome tool called Kayenta, which hooks into their Spinnaker deployment platform. So please do have a look at that. It also hooks into Prometheus, and I think Datadog and a few other ones as well. But more and more companies are looking at canary analysis and trying to automate it as well. But it does impact the developer experience quite a bit. In my experience, particularly sort of more traditional teams, they get a bit nervous and sometimes quite rightly about testing in production, about diverting real user traffic to a kind of experiment effectively. Particularly some financial teams, they, for governance reasons, they can't do this kind of thing. But just have a think about this question. How quickly do you need user feedback? Do you want to be continuing experimenting, or do you want perhaps a little bit more stability? Also worth asking is, do you have a strong opinion on code repository structure? And this is the old classic mono repo versus micro repos. A great blog post by Shippable talks about their sort of journey around these kind of things. But fundamentally, if you're running a mono repo with lots of different services in it, coordination of integration and testing across services is generally easier. There's lots of talk about Google's mono repo. You can check it out, and kind of refactoring across it's nice and easy. Looking for dependencies across it is nice and easy. The trade-offs, though, is it's all one thing. It's all one big mono repo, and it's a lot of code to deal with. Google have even got different tools like Bazel to optimize the way they build from the mono repo, because if you're not careful, as soon as you've got a lot of services, doing a traditional build with a mono repo can become quite challenging. On the multi-repo side, I like this one. I've got the most experience with this, so it's kind of anecdotal, I guess. There's clearer ownership. Sort of teams own different repos associated with various microservices, various products. It can promote looser coupling, I think, sometimes. Within a mono repo, it's kind of like when you had a monolith, it's easy to cheat sometimes, kind of sneak around the back and highly couple something kind of accidentally. But refactoring and code level standardization across all the services can be really challenging, because everyone's checking out individual repos. You need to really push a lot of the standardization into the pipeline. So you need to do things like linting, code quality checks, security checks, all these kind of things. You need to agree on these kind of things and push them into the pipeline, rather than relying on people to sort of be more judicious sort of with their use of things. So, in a monorepo, it's so you can sort of look at examples easier, and it's easier to kind of to assure a sort of homogeneous approach across all the code because it's just one repo. Also ask yourself, do you want to implement guide rails for your development team? This can be a contentious issue sometimes. When I say guide rails, I mean kind of controls, for want of a better word, guidelines into tooling you can use, and sort of maybe hiding a few things or locking a few things away that people sort of to guide people into do good behaviors, basically. Now, larger teams and more enterprise teams, in my experience, often do want to provide comprehensive guide rails. I've had a lot of success with things like OpenShift in enterprises, things like Cloud Foundry, because you can provide a more standardized workflow. This allows developers from different teams to swap very easily, because once they've learned the workflow and the tooling once, they can jump between teams. So there's a lot of advantage by doing this kind of thing. But my experience, I've done a lot of more work recently with startups and SMEs, and the teams there's often 3 or 4 teams, say, within a smaller company, still looking for kind of product market fit, or just getting their sort of feet in the market. They value team independence themselves. They don't want guide rails. They want to be able to do anything, no matter how crazy, but they will take responsibility for it. Or you can kind of go for the hybrid model, the paved road, or the paved road paths we looked at just a minute ago, where you perhaps offer a kind of platform, the paved road, but you allow individual service teams to go off, kind of, and do their own thing. But there's that understanding that if they do have the freedom, they have the responsibility. So if you're looking for something that's a bit more, perhaps more strict with the guide rails, definitely have a look at OpenShift. There's a nice blog post I've linked there. They're doing some very interesting sort of work over and above the Kubernetes platform itself. How much platform should we build? Should you build, kind of thing? It's always an interesting question, and I'm a big fan of Simon Wardley's stuff. So if you go to my talks, you often see me mention Simon Wardley along with Kelsey Hightower. But many things are interesting in Simon's work, but I particularly like a model he talks about with regards to pioneers, settlers, and town planners. And kind of the pioneers are the people that are, blazing the trail. When you're a startup, you're looking for product market fit, you're experimenting, you're prototyping. That is a pioneer. Settlers are taking the ideas from the pioneers and making them a bit more stable, a bit more robust. And the town planners are taking that even further. They're kind of, pulling out sort of components, modularizing, and almost laying the platform for the pioneers to build the next iteration of their prototypes. And Simon talks about every organization has this combination of pioneers, settlers, and town planners, or ideally should. And depending on what problem your team is solving, you're probably going to be in sort of one of these 3 areas. And I think for me, at Datawire, we've often talked around calling this sort of notion of whether we're prototyping a service, whether we've got a service in production effectively, or whether we're running mission critical services. If we're prototyping, going back to the previous slides, we often like local development, very fast. You can spin everything up. We've only got a few services when we're prototyping typically. We maybe use something like telepresence to do some kind of hybrid development, but we like canarying. We like releasing stuff to live as quickly as possible, getting user feedback, and basically iterating as fast as we can. Frequently, we choose mono repos in this case over multi, just because it's easier. We're a smaller team at the moment. We're working together. And in terms of guide rails, well, I put YOLO. Basically, we don't want guide rails in this space. We want to be able to go as fast as we can. Typically, teams with working in this space, their skill sets are cross-functional. So you expect them to be a kind of hybrid, a software developer, SRE, ops person, that kind of thing. When you've got the service, you've kind of got a bit of product market fit. It's kind of productionized. We still do a lot of local testing, a lot of hybrid testing using things like telepresence. We also canary. We want to get fast feedback, but we're also probably increasing our pre-production testing. We've got a few more users now, so we want to put a slightly higher guarantee on that anything that does make it to a canary is more successful than perhaps we were comfortable with prototypes. Prototypes get out as fast as possible. Production, a little more careful. At this stage, you often split multi-repo, in my experience, and guide rails, you're starting to want some kind of limited guide rails at this stage. For mission critical apps, you've got the kind of hybrid local testing thing, depending on how big they are. This can be quite challenging if you're working with legacy systems as well. So this is kind of an area that's a bit perhaps unclear. We typically, with mission critical apps, focus a lot on pre-production testing. Maybe do a bit of canarying as well, but we're often investing in testing functional parts of our app. You're sort of doing BDD and doing things like that. But we're also focusing on testing the non-functional aspects, the quality attributes, like performance, like security, that kind of stuff. By this point, we're typically in a multi-repo situation, just the sheer scale of how we're working kind of thing. And you do often want stronger guide rails in this situation because there's bigger teams by virtue of being more people. The communications are often stretched as a sheer sort of basic communication primitives. If you've got like 100 people in your department, there's like 99 relationships you've got to maintain. Therefore, having some guide rails to remove some of those necessary conversations once you've agreed on how to do certain things is quite valuable. So where to focus? And I think if you're prototyping, I often recommend getting started with the CI/CD part of the experience. You want to perhaps have your own local tools. Your team may be iterating as fast as possible with canarying, but you still need this pipeline. You need the ability to, package up your app into a container, do some kind of, basic testing, and push it out into production, out into live. When you move into sort of more what we're calling the production space, on the setlist space, I often recommend then focusing on the scaffolding. So when we're spinning up a new service, I consider the scaffolding kind of the stuff that I get when I, initialize a new service. I probably like, hooks for various tests I've got to implement if I spin up a new service. Maybe I use like Yeoman or some kind of templating system that creates me a directory with all my code, with a Docker file, Jenkins file, Kubernetes YAML file, these kind of things. And it's maybe got a basic Java service outline or something with some hooks for tests. It's also got some hooks and some slots in for things like observability. So, as soon as I crank the handle and get a new service, it's automatically linked in to, say, Prometheus, or automatically linked into the alerting system. I find at this stage, having the scaffolding, making the cost as low as possible to crank out a new service or upgrade services is where the value's at. You still need CI/CD, but scaffolding is really important. With the mission critical stuff, I find testing is our biggest bugbear here. We need to be able to recreate environments, to recreate data. I don't know if any of you are following along with .mesh. Luke and the team working on some very interesting technology around being able to pre-can data, capture data, and ship it from production to dev and test. Obviously, GDPR issues there. If you're in Europe, you've got to think about how you store that data. But the .mesh team are doing some really interesting stuff in this space. I'm definitely keen to see what they're up to. But those are my kind of tips, and depending on where you are in your team, perhaps where to focus on some of the developer experience. Moving on to more of the sort of some tooling and techniques, I think we're not too bad for time. What I would say is, there's definitely a pattern emerging for Kubernetes for ops. Kubernetes is pretty much becoming the sort of de facto container orchestrator as a service. Yeah, I've done a whole bunch of stuff on Mesos in the past. I use Amazon ECS and other tools as well. But Kubernetes, all the cloud vendors basically are coming up with a hosted Kubernetes offering. It's kind of becoming the new cloud brokerage platform in my experience. I worked on a few cloud brokerage platforms before. Because of this, I think from an ops perspective, you've got a lot of potential to impact the developer experience. Kubernetes itself is highly extensible. The team that initially developed Kubernetes, Craig and Joe and the team, they really thought about the primitives and the API design. And I'm seeing more and more teams now take advantage of this, building custom controllers, using the operator pattern. And I saw Nico's talk, I mentioned it at KubeCon New York. Shopify have this thing called Cloud Buddies, which are kind of like they are custom controllers, kind of like operators. But what they're doing is they're codifying a lot of their knowledge into these extension points. So the Cloud Buddies, like Nico talked about, how they have these name buddy where it automatically sorts out all the DNS registration, all DNS naming. They had a Redis buddy and an Elasticsearch buddy that developers, rather than creating all this, complex Kubernetes YAML, they created a very simple kind of resource definition based on this custom controller and custom resources, and it spins them up and it manages their Redis instance for them. It manages, their Elasticsearch interface. So do please check out operators. I think I've actually got a very interesting blog post by one of the teams. I think that's the Admiralty team, talk about how they explored custom resources and controllers and so forth. I think as a platform operator, as a platform engineer, you can really add a lot of value to developers by potentially creating custom resources, custom controllers. From a development and deployment perspective, now apologies, this slide is a bit of an eye chart, but there's a lot of info here. these are the tools. I've got a link to the blog post I've got these from, but these are the tools from a development perspective I think are super interesting and worth keeping an eye on in terms of developer experience. So there's Draft, which is coming from the Deus team at Microsoft. It's automating the kind of inner loop of build, push, and deploy. You can actually do a kind of like I talked about scaffolding. There's a draft, a draft init command that creates you some kind of scaffolding, and then you can then do this inner loop of build, push, and deploy. It handles all the kind of building the containers and pushing to Kubernetes for you using Helm under the hood. It's a nice tool to kind of get that experience as a developer fast, though you are relying on external Kubernetes. Because if you're just doing everything local, it's very fast, but if you're working with the cluster, it's a bit slower. GitKube is aiming to be more like a Heroku experience, more like Cloud Foundry, where you do a Git push. You don't even need Docker on your local machine or Kubernetes, and it pushes to there's an operator in the cluster effectively that builds the container and deploys it, and you can test in the actual cluster. Very interesting. Scaffolding, kind of similar thing. Scaffolding does provide a dev and a kind of CD mode, which is interesting. It can watch source code, so you get that kind of fast, developer experience. Again, you're coding locally. It's watching the code, building the container in the background, and pushing it up to Kubernetes. Forge from DataWire, similar kind of thing, automates the build, push, and deploy. You can template all your Kubernetes config or your ambassador config, and you can use telepresence with it as well and so forth to do very fast loops developing locally. From a more deployment perspective, I mentioned things like Helm, package manager for Kubernetes. It's deploying and managing sort of ready-made charts in addition to charts that you've created as well. So Helm is a really nice thing to look at. KSonnet, kind of similar thing, defining Kubernetes manifests in something called JSonnet. It fundamentally lets you create sort of composable config and services. This is quite nice from a sort of reusability point of view, from a packaging of your application for deployment. And then a couple of sort of more random ones, which are super interesting to watch, is Metaparticle. Saw Brandon talk about that at I think it was KubeCon last year. And it's a kind of standard library for cloud native apps, but it's language specific. So there's Java bindings for, creating a Kubernetes config. There's language bindings like Go for creating a Kubernetes config thing. So it's a very different approach to probably the other approaches here, but it's very interesting to watch. Brandon obviously a super clever guy. I always pay attention to what he's up to. Kind of similar to this is a language called Ballerina. Now, I covered this one on InfoQ a while ago. It's a new microservices programming language. It comes from the WSO2 team, and it's got some very interesting primitives around developing microservices, event-driven microservices, but it also provides annotations. Now, I've seen some Java examples, had a little play around. You can sort of do the Kubernetes annotations, Docker annotations, and it will create all the Kubernetes config files for you, all the Docker config files for you. So these are some interesting choices. If you're a developer, if you're an operator, these are all very much emerging kind of developer experience tools. Definitely worth a look. I appreciate it is a lot to take away, and maybe you don't want to start here, but maybe you want to start somewhere else first. But if you are looking for kind of these tools, know that they're out there. You don't need to sort of start from first principles. I think I might have missed the slide. When I share the slides, I've got a link to Shahid and Matt Farina's blog posts. They're the two blog posts that actually I've got a lot of that info from, so I must share them later on. Apologies to Shahid and Matt. I haven't forgotten you there, but I must have deleted that slide accidentally. But one pattern I will say is that in addition to all those tools I showed you just a moment ago, most of them are CLI tools. Most of them are command line tools, and not every developer is comfortable working at the command line. So I've noticed, like Nico, when he talked about Shopify, they've built a very simple UI that allows developers to initialize new services, initialize new products, and do everything that kubectl or kubectl allows you to do, but they do it via they do it via UI and via an API. So the platform team at Shopify kind of control the experience, provide some guide rails, so to speak. I even see similar things in OpenShift and so forth. So just something to bear in mind is how comfortable with the developer experience are your engineers? Are you as an engineer? How comfortable with the CLI versus some kind of UI? Obviously, you probably have to invest in building your own UI unless you go with something like OpenShift or that kind of tool. But it really is critical how you expose this kind of functionality to developers. That's my kind of main point there. With continuous integration and continuous delivery, my fundamental advice is make it easy to do the right thing. I think the lowest kind of thing you need to do, the lowest common denominator, is making pipelines creatable via self-service tooling. So whether you use Jenkins, or Jenkins X is super interesting in the Kubernetes space, we use Circle CI quite a bit, Travis, you need to allow developers to create a pipeline for their service. Or perhaps when they create, so you know, the service, when they initialize the service, the pipeline with all the key hooks and slots is created for them at the same time. You do want to bake in hooks and slots for things like testing, things like observability. I mentioned this already. You want to make it super easy for the developer to do the right thing. Super easy to expose metrics, super easy to dump logs in the correct place, super easy to do security testing, for example. And testing of NFRs, I would say, you know, non-functional requirements or system quality attributes is really, really important. And the fact that we're now packaging code in containers and, you know, deploying that onto Kubernetes and deploying that onto cloud adds even more layers of abstraction where things can go wrong. You know, more abstractions makes our life easier in terms of understandability of core abstractions, but it can provide places where things can go wrong. So you definitely, I've got another talk actually I've linked here where I've gone into a lot more details, but you definitely want to look at things like basic code scanning, sort of basic vulnerability scanning. You want to look at things like dependency scanning. So OWASP have got a very nice language agnostic tool to do dependency scanning. It kind of looks up against the National Vulnerability Database to check that your dependencies you're bringing into your service are not out of date or vulnerable. I know Sneak or Snick have got some very interesting commercial offerings in this space. And the same, you want to static image scanner as well. You know, Aqua do some fantastic work around this. Many of the bigger companies like Docker and CoreOS offer static image scanning. There's also an open source tool called Claire, that came from the CoreOS team, and awesome gent linked in the slides, but called Armin has created a Docker container to build Claire, which you can then use to scan other containers. So there's no excuses really to do all these things. You should be scanning your code for vulnerability, scanning dependencies you're bringing in, and clearly scanning the images. Even if you know it's not your image, you want to scan it because you want to know what you're pushing into production. Yeah, these things are super important. Security, no-brainer. Highly recommend testing performance. You're looking for trends. If you know start adding more functionality to a service and the performance goes down, you definitely want to know that's kind of going wrong. And things like quality. I often run in the Java world, a Sonar Cube, and in Ruby world, I ran Code Climate. You want to be checking architectural qualities so that your new microservices don't become new monoliths. Yeah, that's the key thing. So test things like complexity, code quality, coupling, cohesion, that kind of stuff as well. I think another key pattern I'm seeing in terms of developer experience is what I'm calling layer 7 deployment control. And it allows basically fine-grained control of deployment. So Kubernetes, you can do rolling upgrades, you can do kind of quite nice releases, but you can't easily control at the layer 7 at the app level how you want to divert traffic. Maybe you want to do some canary testing, for example, and we are seeing with the emergence of Envoy proxy, a fantastic data plane, we're seeing other tools being built on top, other control planes like Ambassador, like an open source API gateway. We're seeing Glue, which is again is an open source product around gluing functions to a gateway, and Istio, the kind of open platform for service-to-service comms. We're seeing lots of control planes opening up now that are taking advantage of the data plane of Envoy. They're providing very fine, or the Envoy is providing very fine-grained control, so we can divert just one user, for example, to a service. If we're doing debugging, we can divert a cohort of users to do some kind of canary testing. But the key thing in terms of developer experience is how do we offer that to our engineers, our developers. We're still very much working on that at the moment. The 3 control planes there offer subtly different variations of how to do this kind of thing. Definitely recommend checking them all. Ambassador and Glue tend to focus more on the north-south kind of traffic, and Istio is more on the east-west kind of cross-service traffic. But they're all fantastic control planes onto Envoy. Just finally, it's coming close to time now, so I won't go into this in too much detail, but in terms of observability, it is an essential part of the kind of the feedback loop. We're coming up with hypotheses, we need to test it, we need to validate both from a tech point of view and a business point of view. So monitoring, logging, and tracing in my mind is super important. Like getting them in early to a project is really valuable. And I've mentioned it before, but I'll say it again, kind of if you're working on building some scaffolding, build in hooks and slots to make it super easy for your development team to plug in to what you're offering at the platform, to plug into Prometheus, to plug into Elk Stack or Humio, that kind of thing, and also make it super easy to get the data for the user, provide, say, dashboards. I know that Matt Klein from the Lyft team talks a lot about how they have global health dashboards. They're kind of aggregating data, showing the health of the system overall, but they also have individual service dashboards. And Matt showed us actually at a talk recently in KubeCon, you can even do service to service kind of checking on their dashboard. So you can select one service from a drop down of services, select another service that it talks to, and you can look at all the kind of top line metrics in terms of latency, 500 exceptions, all these kind of things. And it was really nice. As a developer, I could really see value out of these dashboards. I can get a global overview, but I can drill into the actual individual services, which is very powerful. But these things, in terms of developer experience, need to be thought about quite early on, in my experience. Sarah Wells from the FT, financialtimes.com, did a fantastic talk a couple of years ago, I think now, at one of the KubeCons around observability, and the FT have migrated to a bunch of Go and JavaScript services, microservices, and they've really put a lot of thought into this observability piece, and they've put a lot of thought into alerting as well. So if you're struggling with kind of things falling over or wanting to know how to craft alerts, really recommend Sarah's work here. Obviously, I've got to shout out Cindy Sridharan. I don't know if I've got a link in this talk, but just Google Cindy Sridharan observability. Her and Charity Majors are doing some fantastic kind of thought leadering in this space. So Cindy's got a mini book out on O'Reilly, which is well worth a read as well. In fact, I may even put Cindy's book in before I publish the slides, because it really is a good read. So that's pretty much wrapping up all I wanted to say today. I appreciate this has been a high-level view. I'd love your feedback, to be honest. Twitter, email, whatever. If this has been helpful, how it could have been better. Bear in mind it is only 40 minutes or so. But I'm trying to give a sort of a thinking point around the developer experience being about minimizing the friction from us coming up with an idea, coding, creating config, to providing business value, and how we actually observe and get that feedback loop going. I've definitely found, I work with teams, we built a few platforms on Mesos and on Kubernetes, and how we constructed the platform massively impacted the developer experience. And with hindsight, and it's always easy to say this, but with hindsight, I wish I'd asked a few of the questions that I asked in the presentation today before we dove in and started playing with some of this stuff. We started working on these things. So hopefully, even if I haven't given you all the solutions, I've at least given you a few thinking points if you're looking at this space. The bottom line is you need to intentionally curate your experience of a bunch of things. Whatever role you play, whether it's dev, QA, ops, platform, SRE, test, PM, we need to think about all the technical components, such as local development and testing, how you package apps, how you continuously deliver them, how you control the deployment, and how you observe these things. Always bear in mind that whatever framework you build around your application, that might cost you in terms of opportunity. You're spending time building a PaaS rather than building business functionality. There's always a trade-off there, but it's one you need to be very intentional about making. I've definitely learned a lot from Nico and Shopify. They've got a lot of value out of their PaaS. But I've also worked with a lot of companies that have got a lot of value out of things like OpenShift and Heroku, because they simply want to get to market as fast as possible. But regardless of what you need to do, or regardless of what you want to do, you need to curate the experience of these things. That's it. Love your thoughts on email, db@datawire.io. You can hit me up on Twitter @DanielBryantUK. There's a kind of summary of this presentation on DZone already, and I will put up probably another blog post as well after this, maybe on the CNCF or the Datawire blog and so forth. But at that point, I should say thanks a lot and see if we've got any questions.
Cool. Thanks for the great presentation, Daniel. We have some time for some questions. If you have a question that you would like to ask, please drop it in the Q&A tab at the bottom of your screen, and we'll get to as many as we have time for. With that, we can dive right in. So, first one, this may not be the best forum, but they are interested in how people handle exceptions in the microservices world, especially in event-driven asynchronous services case.
Oh, it's a good question, but as you said, Bob, it's probably a bigger question, isn't it? But
yeah.
Definitely, I've touched on some of this in my shameless plug, but in my book, it's a Java-themed book, but we've talked about things like using exception catching frameworks. So kind of bubbling things up, but not showing the exceptions to users, but using things like Airbrake, which are tools to capture exceptions, and then you can kind of go back and look at the exceptions as of late. That is more, context is key, I think, in this one. You always want to prevent the exceptions bubbling up and impacting the users. But with things like events, I mean, events are fantastic, and they do allow you to replay things. So you can often say replay events and actually understand how the bug was caused, and you can fix the bug and replay the events to watch it. But it also creates some complexity in terms of if you are using, say, an event store and everything's immutable, like you're writing events to sort of an immutable log, you can't really update an event. You've got to go back and you've got to put a new event in and sort of that fixes the old event. So I'll be honest, that one, feel free to ping me on Twitter. I can probably point the person asking the question into some other articles. People I follow in this space are Jonas Bonnier and Chris Richardson. They are both real good thinkers in the eventing space, and I think I'd sort of point people to those articles first of all.
Cool. Next one. Can you compare Kubernetes and HashiCorp's Nomad-like solutions? Does Kubernetes offer some advantages?
Oh, so yeah, I've only used Nomad, for example, in experimentation. I've not used it in production yet. I'm a massive fan of HashiCorp, and to be honest, who isn't? HashiCorp do some amazing tools. But what I've seen from a Nomad, it was an even simpler kind of proposition to, say, Kubernetes. And again, not bad, it's purely trade-offs. So one of the key advantages with, say, Nomad, you can run static binaries rather than sort of compiling things in containers. I can definitely point people at some interesting articles if they want comparisons. At the moment, most people I'm working with happen to be Kubernetes, so that's where my kind of expertise at the moment lies. But I definitely recommend if people are sort of debating, do some research, because your choice of Nomad versus, say, Kubernetes will have a longer term impact. I had a similar problem when I was looking at Mesos a few years ago. About 3 or 4 years ago, we worked on a project. Kubernetes was super young at the time, so we went with Mesos, but that does have knock-on effects in terms of how you operate the platform and so forth. But I think Nomad, Kubernetes, Amazon ECS, for example, they're all fantastic tools, but they all come with various trade-offs. And I think the person asking the question, identify their context, identify your pain points. So what for you and your team is causing you the most problems, and then look at the offerings of the corresponding products and kind of go with the one that suits you best.
This should be a quick one. What is NFR?
Sorry, if I didn't explain NFR, it's a non-functional requirement. I hate the name non-functional. Other people sort of call it cross-functional requirements, or the traditional term was system quality attribute. It's things that we don't think as functional requirements, but they are equally critical. They are things like security, things like reliability, and things like extensibility.
Okay. Any opinion on Prometheus scalability?
To be honest, it's not my expertise. Some of the other DataWire folk would probably be able to answer that one much better than me. I've mainly sort of used Prometheus, so to speak. I haven't got much experience with scaling it.
Could you offer any thoughts on SIG service catalog with respect to everything else you presented?
Oh, that is a good question. And again, my expertise on this one's a little bit limited. So I'm going to probably caution that one and say, no, I need to be a bit better educated. I keep bumping into this, but I just, the projects I'm working on haven't led me down to explore that path in sort of full depth yet. So I'll hold off, maybe write a blog post on that one or something. It's a good question, actually.
Nice. What are the best resources for constructing the platform? There is overwhelming documentation on different options, but no coherent playbooks about how to put them together.
Yeah, that's a very good question. And I literally had that question with a client like last week or so. And I think the person asking questions already hit the nail on the head. There isn't really a comprehensive guide yet. Someone actually asked me for a book they could recommend. I could recommend, and the Kubernetes book by Kelsey and Joe and the team is fantastic, but it focuses more on Kubernetes as opposed to creating a platform. The honest answer is you do kind of have to knit stuff together. I'm sure, given enough time, 2-3 years, whatever, we'll either see the playbook being out there. Someone will write a playbook. This is all the things you need to knit together. Maybe someone listening to the webinar could actually do that. Or we may even see a move, serverless and things like that. Obviously a big buzzword, but serverless is becoming very popular. Some of the tooling is kind of maturing around that as well. So we may even see a move towards not building our own platforms, maybe more of, we'll actually sort of see more offerings around Kubernetes, more offerings around the cloud vendors that actually remove the need to glue some of these things that we do need to glue together now.
Oh, it's actually close. What are the best resources? Oh, that was sorry. We're struggling to balance infrastructure security versus developer freedom. Do you have any magic bullets?
No, anyone who's worked in the industry for like more than a year or two knows there is no such thing as a silver bullet,
Nope.
as Fred Brooks said. Yeah. So it's a real tricky one. I've worked with some companies. There's a lot of stuff going on at the moment in the robo advice space in the UK, and a lot of financial companies I'm working with, that they really struggle with this stuff because obviously security is a massive thing to them. I do recommend doing things like value stream mapping, taking a step back, maybe a bit more non-techy. But value stream mapping, you can basically map out from idea to value in production all the things that happen, all the stages that happen. And you can, with value stream mapping, you can often identify pain points. And when you've identified those pain points, they are areas to address. So if your developers truly can't go fast enough, well, that's something to focus on perhaps more than the security. Whereas if security is more of a roadblock, if you're having incidents, for example, you want to focus more on security. But in terms of if you've got the balance kind of right, in terms of the actual sort of, there's no issues on either side, it's going to be a constant friction point. Developers in general, I'm more of a developer, I guess, I can identify with this. We want to go fast, we want to be delivering value, but I also totally appreciate the need to be stable. So it's really having those conversations. It's one of the things I do as a consultant is get InfoSec involved in a project early on as possible. I've done a few, I've sort of gone into a few migration projects where InfoSec have not been consulted, and then if we do try and pull them in late, quite rightly they get annoyed and say, my God, this stuff's like containers, Kubernetes super insecure. And obviously it's not the way you deploy it is kind of key, but getting the conversations going, getting everyone comfortable, identifying the value stream, the problem points, that will save you a lot of pain further down the line.
I just went through doing that sort of thing for a FISMA moderate situation, and getting them involved early is definitely really important.
I hear, yeah.
Let's see. Spinnaker and Kubernetes allow the CI/CD with code promotion as pipeline and tailor the workflows for your business. Any thoughts on it?
Sorry, Bob, what was that question?
Spinnaker and Kubernetes allow the CI/CD with code promotion as a pipeline to tailor the workflows for your business. Any thoughts on it?
I hope I'll answer this question correctly, as in knowing the context there. I'm a big fan of Spinnaker. To be honest, I've got the most experience of late working with Jenkins, working at Jenkins X and so forth. But in terms of the pipelines and the promotion pieces, I think it's super interesting. The Kayenta offering, the kind of automated canary analysis, has caught a few people's eye that I work with. So I think Spinnaker is a great tool. It is. It's got trade-offs in terms of sort of coming from the Netflix model, and it's been a little bit sort of molded towards Kubernetes now, but some of the primitives are more towards IaaS and so forth. So yeah, I hope that's a few thinking points there. To be honest, I can definitely point people at a few blog posts I've read, and if you're going to make a choice between something like Jenkins and Spinnaker, I definitely recommend having a play. I've used many things over the years, Go, CD, and Travis and stuff, and they've all got plus and minuses. So you need to understand your context and map it to what the offerings are.
Let's see. You have talked about several options for each tool and pattern. Which one are you using with your team?
So as a consultant, I'm working with multiple companies at the moment, and with DataWire, as in like DataWire is my main gig at the moment. So in terms of, we're doing a whole lot of stuff, with Ambassador. So Ambassador is a DataWire tool. It is open source though. So it's an API gateway. So we're working with clients to it's a kind of Kubernetes native API gateway, and it supports canarying, things like that. So we do a whole bunch of work with Ambassador at the moment. Lots of work with Istio as a kind of east-west control plane. I happen to because my background is mainly Java, so I do a whole lot of stuff with Jenkins. Jenkins is my main CI/CD tool, but we are using Circle as well. Excuse me. And we are experimenting with things like, we've got Forge at DataWire we use quite a lot, but we're also experimenting with things like Draft. So the tools in this space are very much developing, I think. So the kind of clients I'm working with, a lot of them tend to be more, just in the moment, more startup-y, more leading edge. They're happy to be at the CLI. They're happy to play with some of these tools. Whereas some of the more enterprise people I chat to and do more high-level consulting, they want more strict guidelines. So there I see more things like the Shopify team. They're building their own tooling on top of all the other things.
Do you follow the 12-factor app model for a better dev experience? How do you compare it with your approaches?
The 12-factor model is, super interesting. So Yet in general, in my book, a shameless plug, I talk about this quite a bit. And Sam Newman has got some fantastic observations. I mentioned Sam's talk earlier on in the presentation. He talks about this sort of not necessarily being a cloud native kind of model of 12-factor. He was saying cloud native truly is something like serverless, offering a pure, you're just writing code and deploying it into a platform, that being truly cloud native. But I think a lot of the principles behind the 12-factor app, and I think it's Kevin Hoffman did a 15-factor app, so you can have a Google 15 factors. It's a little mini O'Reilly book, because more factors is clearly better. Yeah, we all think that. But Kevin's got some really interesting observations over and above the 12-factor app. Fundamentally, though, Heroku inspired. They were one of the original PASs. Nearly all the advice stands the test of time with the 12 factors. And you can literally kind of, see if you're building stuff for Docker and Kubernetes, you can literally go through the 12 factors. And if you sort of check them off in terms of paying attention to them, I guarantee it will make your architecture and your developer experience smoother.
Cool. If you have plain simple containers in production, what would be your starting point to introduce a service mesh? Try one aspect like tracing or go all in with Istio?
Oh, that's a great question. Probably, to be honest, more context required. If they've got straight containers, as in, I'm not sure if the person was running Kubernetes, for example, but I definitely wouldn't recommend going something like Istio unless you've got Kubernetes. I mean, I've never played with, you can spin up Istio on its own, but that might be more pain than it's worth. I kind of think with the tracing, you sometimes have to go all in, or pretty much you do have to go all in terms of propagating the header. You apply a correlation ID at the start and you propagate the header down through the apps. So the apps do have to be a little bit aware to propagate the headers to get the full traces that you can then correlate together. One project we tried to retrofit Zipkin at the time, and it was really hard. So putting it in the start is a lot easier, I guess. But I think if I'd recommend probably experimenting. I think Istio is evolving in a rapid clip. I looked at Christian Poster for a lot of my kind of guidance on this stuff, and Nat Klein. Christian's actually writing a couple of books, I think, on Istio. I think give Istio 6 months, a year, it's going to be even further advanced. And I know, chatting to Yasmin from Google around this for InfoQ, she was saying that the goal is to make Istio ambient. So eventually Istio kind of disappears into the platform, disappears into the Kubernetes platform. So in some ways, if you haven't got a direct pain point that something like tracing or a service mesh will solve, maybe by waiting 6 months, a year, it'll actually be easier for you to integrate Istio into your stack. I would say Istio is fantastic, but it's not fully production ready yet, and don't underestimate the effort it will take to put in a stack.
Okay, cool. What was the title of the Kubernetes book you recommended?
It's by Kelsey Hightower, I think Joe as well, and someone else. Apologies to the person I've forgotten there. Is it Kubernetes Up and Running? There may be a couple, but I can ping. I'll make sure I put the link in the slides when I share it. But the main thing is, Kelsey has only written one book. So if you search for Kelsey Hightower, it's on O'Reilly.
It is Kubernetes Up and Running.
Thanks, Bob. Awesome. Yeah, I couldn't remember. There's a couple of ones floating around now.
Okay. And last question. What is the difference between Istio and Ambassador? What is all about this east-west thing?
Oh, sorry. Yes, I'm so used to explaining term. So when I say east-west and north-south, so north-south traffic is typically the traffic coming into your system. It's the ingress and egress of the service, your system boundary. It's basically like where your user traffic comes in. So we call that north-south. The east-west traffic, it's an old term from data center days, is in our sort of microservice world, it's the service-to-service traffic. So you have, when a service wants to communicate with another service within your network perimeter, we call that east-west traffic. And the deal with Ambassador and Istio, so they both use the Envoy proxy to do all the kind of networking magic under the hood, but they're two different control planes. So Ambassador is a control plane for the API gateway. It allows you to write annotations in your Kubernetes config, and you can control everything at the point of ingress like you would with the normal API gateway. Do rate limiting, fault tolerance, all that good stuff, service discovery routing. Whereas Istio is more, at the moment at least, it's more east-west service-to-service comms. You can set up sort of canarying, fault tolerance and everything at the service-to-service communication level. Now, there's nothing to stop you, and I'm actually writing a blog post on this, funny enough, nothing to stop you using Istio, I think, as ingress. I think there's sort of some blog posts emerging on this, and you can even use Ambassador as a kind of east-west thing as well if you want. And Glue, kind of similar. Glue is offering a control plane over Envoy as well. So hopefully that explained. If not, I'm happy to get on Twitter or emails to make it a bit clearer. I think I've even got some blog posts where I go into more detail about north, south, east, west, but that's the fundamental differences.
Cool. Well, thank you for the great presentation.
No worries.
Let's see. That is all the time we have for questions today. Thank you for joining us today to learn about creating an effective developer experience on Kubernetes. The webinar recording and slides will be online later today, and we look forward to seeing you at a future CNCF webinar. Have a great
Thank
day,
you, everyone.
everyone.
Bye.